Have you ever copied a redstone build without understanding how it actually works? Today we're going to fix that. By the end of this video, you'll understand the basic concepts behind almost every redstone machine in Minecraft. Okay, so I have placed a lever, redstone dust, and a redstone lamp. Think of redstone as Minecraft's version of electricity. Electricity travels through wires. Redstone power travels through redstone dust. When power reaches a redstone device, something happens. A lamp turns on, a piston moves, a door opens. Everything in redstone starts with moving power from one place to another. If I hit the lever, the lamp turns on. It is what reacts to the signal. In this example, the lever is the input, the lamp is the output. The redstone dust is simply carrying the signal between them. Here's where many beginners get confused. Redstone signals don't travel forever. Every signal starts at a strength of 15. As a signal travels through redstone dust, it gets weaker and weaker. After 15 blocks, the signal completely disappears. I turn on the lever, 15 blocks, it stops going. That's why long circuits need repeaters. A repeater does exactly what the name suggests. It repeats the signal. When the signal reaches a repeater, has an input and an output, the signal is restored back to full power. This allows redstone power to travel much further. It also causes a delay. If I click on this, you can see the section moving. Each one of these is a delay. So that's 0 delay, 1 delay, 2 delay, 3 delay. And that is for timing of the redstone. If you need several circuits in a line and they need to be timed correctly, you change the timing on the repeaters. But for a simple straight line, you really don't care about the timing. This is just to show you what it can actually do when you have several different circuits. There is an input and output. If I put it the other way, it doesn't work. Understanding comparators. Comparators is one of the most useful items in reading how full a chest is. A fuller chest produces a stronger signal. That's how automatic storage systems know when containers are full. It's called a comparator because you can also have redstone coming in from a different direction. And it compares these two signals. And you can also put this in subtraction mode or additional mode. That is for another topic for another day. There's several different kind of inputs. A lever, a button, a pressure plate, tripwire. You could also have workstations. So the lever creates a permanent signal. A button creates a temporary signal. And it's all based on timing. Pressure plate needs weight on top of it. All of these do the same job. There are different ways of creating a redstone signal. You can even do a lectern by page turns. Tripwire does the same thing. You need a tripwire and string. Outputs are things Redstone controls. Most Redstone builds are simply connecting an input to an output in interesting ways. Lamps, pistons, movable objects, doors, dispensers. Inside the dispenser is a bucket of water. You have two types of pistons. Regular pistons, then sticky pistons. The sticky pistons are the one with green that you have to attach with slime. Regular pistons push blocks away. Sticky pistons push blocks away, then pull them back. That's why sticky pistons are used in hidden doors and moving walls. Both pushed them away. Only the sticky one brings that one block back. Used in doors and redstone circuits that you need to turn and on certain sections of the redstone circuits. Back the way it was. Sticky one pulls the block back. One of the biggest beginner mistakes is thinking redstone only works through redstone dust. Redstone power can also travel through many solid blocks. Understanding this makes your buildings and builds much smaller and cleaner. No redstone dust travels through. Redstone becomes much easier once you understand a few core ideas. Inputs create signals. Outputs react to signals. Redstone dust carries signals. Repeaters restore signals. Comparators measure signals. Pistons move blocks. And most redstone machines are simply combinations of these pieces. In part 2, we'll start building real circuits using clocks, vertical signal towers, logic gates, redstone torches that invert or change the signal, and practical redstone designs. This version teaches concepts, not just parts, which is what most beginners struggle with. One thing that's a bonus that I'm going to show you how to do is if you press F3 in Java on the PC level and change the edit on PC, you can see it's F3 plus F6. You can actually see the power level of the redstone. It is dropping the further I get away. Bonus. Thank you for watching. This is Henry on Craft with Henry. And in the next part, we'll go over other items. There's a spider in the background. Subscribe and like if you want to see more videos. Thank you.